Hello, everybody. I am really excited to do this live stream. Um, and so today we are going to be working on research. So we're going to be reading slash understanding context compression techniques. So I'm really excited to do this. I've never really done a in-depth live stream. I just just don't really talk in my live streams, but I'm really excited to do it today. Just gonna double check to make sure that the volume's coming through. Live streams. I'm really excited to do it today. Okay, everything works awesome. Let me just make this public so that people can actually come through. Awesome. Okay, so we're good to go. I'm just going to close my door so we are ready. Okay, so I have the issue that we're going to be working on today up and ready to go. So yesterday was a lot of coding. Today is not going to be one of those days. It's going to be more of researching. I did some work prior to this live stream. I'm just gonna continue on with the planning and everything for the next voter's local agent. So yeah, I am really excited to do this. Essentially, while I was working yesterday, it was very syntax heavy, execution heavy, not very high level system design sort of thing. But while I was doing that work, this agent, the Claude Code agent, it came across a paper, and that paper is CompactPrompt. It's introducing this concept called CompactPrompt. So today, I just want to go through that paper and see if it's feasible. This is the paper. If it's feasible for us to actually use this, right? So I'm just gonna press View as PDF, so we actually get the paper itself. There we go. So I'm gonna just read through this. I'll use AI to help me out here and there. So I'll probably just download this so that we can use it in Claude Desktop. But essentially what I want to do today is just see if this over here is something that we should implement into our pipeline, and specifically I want to figure out ways that we can essentially use this technology, but then adapt it in a way that it is more specific to our domain, which is, very text heavy, legalese, right? Because we're looking at legislation and like political documents, which are like riddled with like unnecessary amounts of words for saying just like one thing, right? It's not very straightforward, clear cut. So that is sort of the thing that I want to do. I want to first understand what CompactPrompt is, see its feasibility in my agentic workflow, because this was built for agents. And it says that in the abstract, which I read before even doing this video or working on this, but it specifically mentions, as you can see over here, LLM agents. So I know that this is going to be awesome, and something that has a very high likelihood to be implemented. So anyways, this brief was made by the LLM, but here's what I'm going to do. I'm just going to say work that needs to be done, understand CompactPrompt, see if it's a feasible approach, if it can be added to NV local workflow. And then finally, I want to see tweak the current design of CompactPrompt to be more apt for legalese when not. It's because of the way they are written. Alright, so these are the 3 things that we will try to get accomplished. Okay, I think it's very feasible in the next like 2-3 hours. So yeah, I'm really excited to start this and see where it goes. All right, I'm going to be canceling out of there. But yeah. Okay. Alright, so let's start off by just reading this paper, trying to gain an understanding. So I'm just going to have Claude opened up for our help. Takes a awful time to open up, unfortunately, but I'm just gonna open this up in its own sort of folder. Yeah, you do not need to see that. Okay, awesome. So this is fine. Opus 4.7, though honestly Opus 4.6 is also pretty good, but I'm on the max, so like I really don't care about token usage, so I'm fine with this, right? I'm just gonna also just shrink my camera a teensy wincy bit, so that everything is more easily seen. Awesome. Okay, let's go ahead and read this paper. I'm really excited to go into this. And just for a little bit of context before we get into this, CompactPrompt, from what I know, is basically a way of compressing your prompts, because obviously in an agentic workflow you're going to have like system prompts. So it's a way of compressing those prompts, and also the data which is being passed through your pipeline, so that you essentially are using less of token cost, and it's a much more faster experience. And in my case of Next Voters Local, which is an AI workflow, right? We definitely need that, because we use Tavili to like search for things, and when we finish searching for those things, you have these huge amounts of documents which are added into context. And currently I have LLM Linguia, specifically the long LLM Linguia, which I implemented yesterday, as a way of basically managing the context. But I wanted to see if CompactPrompt is a much better way, because the problem with long LLM Linguia is that you have to run this model locally. There isn't really a SaaS service to run like these context compression. Maybe I should make a startup about that. That is surrounding AI infrastructure. It's actually not a bad idea. Well, we'll see. We'll see what happens. But for right now, I didn't really find a service for this, so that's why I am working on building basically a service for that through CompactPrompt. Actually, now that's got me really curious. So just a slight detour to X. I'm curious. Is there any SaaS service that provides context compression management for AI agents? I'll try finding one for LLM Julia and or alternative Cloud Code Web Explorer agents. Thing. Awesome. Okay, anyways, let's build the infrastructure that maybe might become another startup. I don't know. We'll see. Okay, let me read the abstract for you guys, and then I like to do what's called active reading. So I read something, reflect on it, move on, right? we don't really need to worry about all of this. It's just like, about the paper. But let's do this. Large language models, LLMs, deliver powerful reasoning and generation capabilities, but incur substantial runtime costs when operating in agentic workflows that chain together lengthy prompts and process rich data streams. And when it says process rich data streams, it's talking about processing just data which is fed into the LLM as context. So in my case, it would be like the web content. We introduce CompactPrompt, an end-to-end pipeline that merges hard prompt compression with lightweight file level data compression. Interesting. CompactPrompt first prunes low-level information tokens from prompts using self-information scoring and dependency-based phase grouping. In parallel, it applies n-gram abbreviation to recurrent textual patterns in attached documents and uniform quantization to numerical columns, yielding compact yet semantically faithful representations. So basically, just explain this very simply, what this does is it first removes low-level information tokens. So this just means that it removes like the noise of your data. And I feel like that actually sort of it addresses my point over here where I said, we need to tweak the design of CompactPrompt to allow for legalese to be kind of removed. But it already does that out of the box, because over here it's telling me that tokens which are low information, they don't really provide any meaning to whatever is happening, the overall context, they're removed through a self-information scoring, and obviously this is high level because it's an abstract, but it's a self-information scoring which is it basically scores the tokens based off of how informative or meaningful they are, and then it removes the lower meaningful tokens. So I guess it does do that, but maybe in our design we might need to tweak it a bit just so that the self-information scoring mechanism is more indicative of not only having low information but also removing things that are unnecessary. Like they might provide information, but you could say it in lower amounts of words possible. We'll see. And like, for example, legalese versus regular language. Actually use Claude. What is an example of legalese versus regular language? Let's see what it says, because it is pretty ridiculous. See, look at how much is literally said for just one sentence, right? And though these tokens are probably going to be needed for the information, what I'm trying to say is that they could probably be rewritten in a way where we can just remove 50% of the tokens. Maybe that might need to be a layer before the CompactPrompt, because CompactPrompt is more about information level, not just looking at the context itself, or specific domain in which we are in. But we'll see. Again, I need to learn more about this approach. Okay, I'm actually curious what n-gram abbreviation is, because I'm not sure what this means. So that's why we have the beautiful Claude to tell us exactly what we need to know. What does this mean within the paper? Oops. It's publicly available, so it should be able to scrape it. No issues asked. Okay, let's see. And okay, this is describing one of the two compression techniques in CompactPrompt, which is a system for shrinking the prompts you send to an LLM so you use fewer tokens and pay less. Here's what each piece means. Ngram abbreviation. Okay, so it's going like really low level. It's telling me exactly what's happening here. But ngram abbreviation. An ngram is just a sequence of n consecutive words. So like number, I guess n is representing. A bigram is 2 words. Interest expense. A trigram is 3 words, etc. Abbreviation means replacing those phrases with a much shorter placeholder, essentially making up shorthand code. Okay, I see. So ngram abbreviation. So basically, there's like different context compression techniques that it is implementing, and I'm assuming that they did research on like what's like the most impactful that works out, right? So okay, that's pretty sick. I'm not gonna lie. All right. Yeah, in parallel, I know what that is, right? For those who don't know, it just means when you do things alongside each other. I learned this actually like in July, I think, when I was doing like a contract job, um, and I was working with like PHP and like running like a bunch of different threads in parallel. But okay, anyways, let me go back here. Okay, I get what ngram means now. So basically, this is basically saying that if you have a consecutive word, right? For example, interest expense. Um, but how exactly would it do this though? That's what I'm asking. How will it identify if a word or if a series of words are actually relevant to one another to warrant an abbreviation to be made? I think that's the right question to ask. And actually, while we're at it, let me go ahead and just share this. That's pretty sick. Let me just like that. Okay. I've been doing a lot of like posts on X now. But yeah, it's pretty sick. Okay. Okay. I get what what this is trying to say. So basically, what this is trying to say is that um, a part of the way that they're able to actually identify if a sequence of words needs to be abbreviated is based off of the amount of times it happens, because a property within natural language is that usually when words are related to one another they will come up very often, right? It's very rare for words to like be together like pretty often that aren't related to one another. It can happen sometimes, right? It can happen sometimes, like once or twice, but that's not nearly enough to like have this mechanism abbreviate them. So it's just literally pure, as it says on the on Claude. It's just pure statistics or just pure mathematics. There's no like fancy, you know, fancy recognition system in play. It's literally just checking what happens most often and then abbreviating those words that come up most often. So that's n-gram abbreviation. Um, and then yeah, so recurrent textual pattern. Okay, so that's why it says two recurrent textual patterns. That makes sense now. So the reason why it says two recurrent textual patterns is because recurrent textual patterns literally means patterns that come, like text patterns that come over and over again. So that's my bad. I should have um, I should have read that, but awesome. In attached documents, right? Yeah, obviously. Even in our case, it would be like HTML documents, which have like text, right? Or actually, it wouldn't be HTML documents because we get them from Tavili, but it would be like just a blob of text, right? So that would definitely cut down a lot of the thing. I'm curious though. Wait, before I even go any further, does LLM Lingua use compact prompt? Okay. Awesome. So LLM Lingua is a separate prompt compression method. I actually did not read the work behind it, but which I probably should, if I'm being honest. But compact prompt is actually completely new, so it might be a better one for modern LLMs. But okay, so anyways, let's keep moving forward. We're literally still on the abstract. Okay, awesome. So now we understand what the n-gram abbreviation technique is, which is part of this. And it also does uniform quantization to numerical columns. I know that quantization is used to basically like not flatten but reduce the amount of parameters there are within an AI model so that it can run on like lighter, uh, more, or I should say less powerful systems, right? For example, you can get the quantized Quen models, which are based off of the 70 billion parameters, but they're turned into like 8 billion, so they can run on like consumer grade hardware. But I'm curious as to like what it means within the specific context of numerical columns, because some context around the paper is that this paper was built for a like finance company, BNY, which is like a, I don't know what they do, but they do like consulting, I think. But yeah, they're like a financial service company. Um, and because of that, there's obviously going to be the question of like, you know, numerical columns which come from like CSV files, and like quantizing them, which I'm assuming is just reducing the actual amount of bytes that they take up. But let me actually search that up and see. I think we did have it from before, but I'm just kind of lazy to go up, if I'm being honest with you. Does this mean that they reduce the amount of bytes that these numbers take up? Great. I'm supposed to get a question sign. Right, because a token can mean like, and like it can represent any value, right? It doesn't necessarily need to represent this whole thing. So usually it will be broken down to like multiple tokens. Um, But I'm curious as to, okay, after quantization it becomes this number, but actually it shouldn't. In the table that you gave, after quantization, it becomes completely different numbers. How does that make any sense? Because now, yeah, you definitely reduce the amount of tokens because you went from like 6 to 8 to like 1, right? From these big ass numbers. But like, they're not the same. Like, this does not mean this. I thought it would maybe be like scientific notation that they would like use, which would not be a bad idea. So there's a scale factor. Awesome, awesome. So, okay, I get what's happening. So, essentially, what's happening is that it's taking. So, I thought initially that it was about bytes, but that's pretty stupid on my part. It's basically about tokens. It's quantizing the amount of tokens because when you have numbers, right, within like CSV files, they're gonna be pretty large, right? They're gonna be pretty huge, especially in like financial firms. Um, and even in like this can actually be extended to my use case of like civic tech because there's going to be big numbers and like budgets, right? So there's still a lot of like layover and crossover in my domain. Also like population numbers or voting numbers, all of these are huge numbers, and because of that they're not going to just take one token, right? They're going to take like multiple different tokens. And so what we need to do is basically take that big number, put it through a mathematical model which has a scale factor, and that will reduce that big number into a smaller number, which is not exactly the number that you had initially, but it means a number very similar to the number that you had originally. However, you're going to have some sort of loss in that in terms of like the precision, excuse me, and obviously that's a trade-off that you need to make. You can obviously fiddle around with the scale factor to see what loss is comfortable to be made, especially in finance. You probably want a very low amount of loss, maybe under 1%. But in the case of like civic tech, it's fine if it's a little bit more, so we can have a little bit more savings in our domain. So it's actually more useful in our case. But that's exactly what it does, and I feel like they're gonna go more in depth as to how all of this works. Let me just close my door. I feel like they're gonna go more into depth as to like how exactly all of this works out, as well. So I think it's fine, honestly, to not go, become too crazy over it. But yeah, I think. Okay, so they said that first of all, their cost, they were able to reduce it by 60% on these benchmark data sets, which is pretty sick. But yeah, they're able to keep less than five. Like they're able to keep basically 95, excuse me, percent accuracy, which is pretty good, right? I think that trade-off is like worth it. 60% of the cost being reduced for only 5% of accuracy being lost. That if an engineer doesn't take that cost benefit scenario, they're pretty stupid in my opinion. But yeah, let's see how this technology works. But currently, just from this and going a little bit more in depth, reviewing this, basically, by the way, I like to be very thorough on the abstract. I just kind of skimmed through it before the stream. But the reason why I like to be so thorough here is because it provides the groundwork for the rest of the paper. So then if I put in that 10-20 minutes extra effort here, the rest of the paper becomes way easier to understand. But from my understanding, what is essentially happening is CompactPrompt is a way to reduce the amount of tokens that you're using within your prompts and the data documents which are being stored within your agentic workflows, right? It specifically mentions agentic workflows, so I'm assuming that's talking about when it's specifically like optimized for AI agents, or like workflows which are centered around an AI agent, which is what mine is, right? It isn't like a multi-agent system, but there is a subsystem within my workflow which is multi-agent, which is the data discovery platform. But the overall workflow is just like a linear chain which was built through LangChain expression language, right? But it's still an agentic workflow because it's like it was built around the idea of an AI agent, right, doing work. But anyways, off of that yap session, essentially CompactPrompt is used, as I said, to reduce the amount of um, you know tokens that you're using for your prompts and to process the data documents which are being fed into the system, right? In our case, the web data, which comes from the discovery agents. And also, on top of that, the way it does this, that's another piece of information which was given in this abstract. The way it does this is twofold. The first one deals with the text, and the second one deals with the numbers. So in the text, it finds through recurrent text patterns, which is basically just finding out, text patterns which happen often, and specifically consecutive words coming together. So if the word or if the set of words called interest expense, they come up like 50 million times within your text, right? Then obviously CompactPrompt knows that that specific consecutive words, those are related to one another. And because of that, it abbreviates them instead of using their full form. That way, we're reducing that token usage, right? Because now instead of maybe again, this is just a mental model that I'm building, but instead of like interest expense, it'll be IE, right? And if we actually look this up, token expense, token. There's a website where you can like see the tokens being visualized. Gemini will do, it doesn't really matter. But like, let's say you have interest expense, right? And you tokenize that. You can see it's two separate tokens, right? Within Gemini. If we use something else, the tokens will be different. Interesting. Run into an error. See, in this case, it's 4 tokens. It just depends on the model because the tokenizer that they use are different. But let's use like this one, right, which uses 3 tokens. So for these 2 words, you're using 3 tokens. But now through the CompactPrompt, it was able to figure out that through the n-gram abbreviation method, right? So through the n-gram abbreviation method, which runs in parallel, which means that they're running multiple of these n-gram abbreviation processes simultaneously. Because of that, they know that interest expense is being shown a lot in the document, and basically what n-gram abbreviation does is if for n consecutive words, and just being the number of words, and so that can be like 2 words, 3 words, 4 words. Really, it's an exhaustive list. But for those n amount of words which are consecutive, if they're frequently being shown, well then what we're going to do is just abbreviate them. So when we abbreviate them, again, this is a mental model. The compact prompt might do it a different way. But when we abbreviate them, it could be something like IE. It could become something like IE. And now, as you can see, we're only using 2 tokens. So we saved that 1 token that we were using from before. Maybe in Gemini now we're only using 1 token. See? So instead of like the interest expense, right, which uses 2 tokens, now we just use IE and we save that 1 token. We shave that 1 token out. Again, this is a very minuscule example, and this probably does it in such like a much larger scale. And I know that because it's talking about using it in parallel, right? But okay, that's the first method that it uses. Now, the second method that it uses is uniform quantization to numerical columns. And what that means is that you essentially have numerical columns within CSV files, right, or other related documents. And these numbers, they take up a lot of tokens, right? Again, let's use a token visualizer. For example, I don't know, 300 million, right? Pretend, I'm going to use specifically in the context of not finance, of which this paper was based off of, but in like political, the political realm, which is what my agent is being built off of. So let's say that this is 300 million people, which is actually awfully close to America's population, if I'm not mistaken. Yeah, it's like 342 million, right? So it's very, 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 very awfully close, right? So I don't know, let's just do 342 million over here, right? So then what we're going to do is just tokenize it, right? And when we tokenize it, you're going to get 11 tokens, which is really expensive. But now, through the uniform quantization to numerical columns, what will basically happen is this amount of tokens will become lower by completely changing this number. And that's going to happen through a mathematical model. I'm going to show you that in a bit. Just hold on for a second. All right, I'm back. Okay, so what I was trying to say is that you basically have these 11 tokens, and then now through the mathematical model, which uses like something like as a scale factor, right? It will basically reduce this to another number, which roughly represents the number that you have here, right? So, for example, let's say the quantization method takes this and turns it into like a 31, right? So now I shaved off those tokens. I shaved off those 9 tokens, right? So that's essentially what's happening within the second process of the uniform quantization to numerical columns, right? And what they found at the end within this research paper is that they're able to compact the actual information, but they were still able to keep the actual meaningful representation. That's what this is saying. These three words are basically just complex way of saying that we're keeping all of the meaning while reducing the noise, right? Through these two approaches. And they actually have quantified this over here, as I said before. So yeah, they used outdated models like 3.5 Sonnet. I believe this is like gone now. Like I think Anthropic, they discontinued it. Let me actually see. Discontinued. Yeah, it's been retired. So very long ago. But that's fine, honestly. This is still a 2025 paper, so it's pretty recent. Um, but yeah, let's actually get into that work itself. Uh, yeah, okay. Cool. And then I actually want to see if it's feasible to build something on this compact prompt implementation. Okay, while this is happening in the background. Okay, so it's not too bad. Um, no, not yet. But the actual compact prompt specific features are the n-gram abbreviation and the uh, number quantization technique. Okay. So the two things I just talked about, those are the new contributions which were made by this research paper. The rest of the paper, like when it's talking about, um, when it's talking about related works, right? Over here in part two, which goes down to like talking about hard prompt pruning and stuff like that. This stuff over here, that's already been abstracted away by uh, my implementation of long LLM Lingua, which is just based off of the work of LLM Lingua. I do want to learn this at a more low level, um, I guess low level understanding, but for right now, I think it's fine to just have it abstracted away. So basically, the two novel things that we will implement, which is things that come from this paper, are the two things we were literally just talking about for like 40 minutes. So that's great. Good return on investment there. Okay, let me just go through the introduction. I'm just going to fly by this. The introduction doesn't seem too hard or too academically inclined. And then I'm going to skip the related works and just go directly to design. Because the related works is piggybacking off of the work of LLM Lingua. Apparently, that's exactly what Claude is telling me here. Um, right? It's basically saying that the selective context LLM Lingua did the prompt pruning step, which is the self-information scoring and dependence and parsing first, which is actually what it talked about at the start. It basically said, see over here, it talked about where it prunes low-level information tokens from the prompt by using the self-information scoring and dependency-based phrase grouping. These two things, I actually missed them earlier, but these two things, they are not the actual contribution of this paper. They come from previous works. The two things that we should be worrying about, which is not implemented within our workflow, because again, these two things are from the LLM Lingua, which I already have done work on from yesterday and from months ago as well. Just improved the work yesterday. But the two new things that we're going to add is going to be the n-gram abbreviation to the recurrent text patterns, and then the uniform quantization technique as well, because there are going to be a lot of numbers that the agent workflow will be exposed to. So yeah, okay, awesome. Just now that foundation is sort of laid for me, I think it's very beneficial to actually delve deeper into the paper. So yeah, let's do that. Awesome.
तू कोनी जोर बात कर रहा है कोई जोर बात कर रहा है खाली चित्ता जुड़ा
Okay, let's start off with the introduction. Global financial institutions were among the first to integrate large-scale generative models into production systems, driven by the need for operational efficiency and consistent output quality. Prompt compression, the process of algorithmically removing or rewriting superfluous tokens from user inputs, directly reduces computational overhead. Fewer tokens, lower inference costs and latency, and can standardize prompts across users with varying levels of expertise. Prior work has shown that verbose or unstructured prompts not only increase model cost, but also introduce variability in generated outputs. By applying prompt level optimization, token pruning, heuristic rewriting, or LLM based summarization, institutions can achieve measurable cost savings while simultaneously improving response consistency and reliability. This dual impact makes prompt compression a compelling technique for enterprise scale LLM applications. Empirical studies on large language models reveal that a certain length beyond a certain length, adding tokens degrades reasoning performance. So I think it's referring to the lost in the middle problem, where over time there's context rot, which leads to a lower amount of performance, even though you're adding more context to the context window of the AI model. But that's observation based. There's not really scientific evidence behind it. So, anyways, in 9, and these are just research papers. Okay, so it's just referencing to previous research works. Let me go back to where I was. Yeah. So in this paper, a marked decline in various reasoning benchmarks once prompts approach roughly. In 9, a marked decline in various reasoning benchmarks once prompts approach roughly 3,000 tokens, which are well below the context window limits of the contemporary transformer models. Yeah, so it's definitely referencing the loss in the middle problem. Yeah, see? So it talks about it literally here. One manifestation of this limitation is the loss in the middle effect. As an input sequence lengthens, transformer attention mechanisms tend to overemphasize tokens at the beginning and at the end of the prompt, allocating disproportionately less weight to the information appearing midway through. The result is an impaired ability to integrate all relevant context during multi-step reasoning tasks. Together, these findings highlight a fundamental constraint in current transformer architectures. Their capacity to reason coherently over long sequences is inherently bounded. Although prompt engineering techniques such as chain of thought can partially mitigate this effect, they cannot fully overcome it. Practitioners must therefore strike a careful balance. They need to provide sufficient context to support complex reasoning without exceeding the model's effective working window. And them using the word effective is very, very important because the context window of like models can be like 1 million context window, right? Like for example, Opus 4.6 or 4.7 has that. However, the actual working window, right? The effective window where the model is actually useful to the user is completely low, like it's way lower than that. And that's because of limitations like the loss in the middle effect, where overgeneralization happens between the first tokens that are sent and the final tokens that are sent. Sort of like humans, we overgeneralize or overemphasize things that happen at the beginning and at the end of our experiences, be it a movie or like a vacation or whatever. Interesting parallel there. But anyways, yeah. So practitioners must therefore strike a careful balance. I've already said this. They need to provide sufficient context to support complex reasoning without exceeding. Yep. And okay, this is where prompt compression comes in. So this is exactly the work that I've been doing, right? I'm the practitioner, and I've been struggling to strike this careful balance because I need a lot of context to support this complex reasoning, but that can't always happen because of these constraints of the model's working window, right? So using these techniques such as prompt compression, which I've already done through long LLM Lingua, will help us avoid reaching those context windows. In fact, or those limitations. In fact, it was so bad at the beginning because I didn't add any prompt compression. I didn't even know this was a thing, right? I didn't add any prompt compression that I was actually reaching the actual context window limit of like my models, right? I think we're using GPT-4o, so I don't remember exactly what the context window is for GPT-4o. It's 128,000 tokens, right? So we're reaching that amount. Now, obviously, the context that we were sending it did not warrant this amount of tokens, right? And once we reach like I would say around 60 or 70% is what the sweet spot is. Once you reach more than that, yeah, it's over. It's just not gonna work as good. So now I'm obviously taking this more seriously, reading the research papers to actually make this much more better. Like the context management much more better, or engineering. To achieve the previously mentioned balance, two principal classes of solution for prompt compression. To achieve the previously mentioned balance, two principal classes of solution for prompt compression. Hard prompt compression techniques, including selective text and LLM Lingua. I have implemented LLM Lingua already. Soft prompt compression methods such as GIST and 500x compressor. Crucially, all existing work operates on the prompt in isolation, ignoring another major contributor to the context size, in external data attachment. Yeah. No, this is true. I think the way that if I'm being really honest right now, I think the way that I implemented LM Lingua was to have it affect external data attachments, right? Or specifically the attachments that we make from the discovery agents finding the text. Um, but now that I'm realizing it, that's probably not the best way of going about it, because LLM Lingua has been optimized for prompt compression, not necessarily these external data attachments. Um, but yeah, I should probably work on that. Traditional file compressions, gzip, numeric quantizer, reduces storage and transmission costs, but is incompatible with token-based LLM APIs. In this paper, we introduced CompactPrompt, an integrated framework for simultaneous prompt and file-level compression in LLM pipelines that address these gaps by introducing context compression. It is an end-to-end training-free pipeline that unifies hard prompt pruning via token level self information scoring and dependency drive phrase grouping, textual n-gram abbreviation, which constructs a reversible dictionary of high frequency multi word expressions in attached documents and replaces them with unique, short, human readable tokens. Numeric quantization, which maps floating point columns to fixed bit integer codes under user specified error tolerances, preserving analytical fidelity, which I'm assuming just means um, like the usefulness of it. Very interesting. Uh, yeah, the degree of exactness with which something can be copied or reproduced. Awesome. So this is exactly what we've been talking about, but now I'm just getting a more deeper like level of understanding of exactly what is happening here, right? But um, yeah. So essentially, if I just want to gather my thoughts here, essentially what is happening is, based off of the introduction that was given to me, the issue that this approach compact prompt is trying to solve is that we have already we already have prompt compressors, right? And these prompt compressors are used to basically overcome the limitation that AI models have, which is the fact that they cannot handle large amount of context, but they need some amount of context which is large to allow for complex reasoning to occur. So a balance needs to be struck, and that balance happens through the prompt compression techniques. And I've personally used those prompt compression techniques through the means of LLM Lingua. However, LLM Lingua is specifically made for prompt compression, not really external data attachments. So what is going to happen is that this basically this compact prompt technique or framework, they calls it a framework, so I'm going to call it a framework. This compact prompt framework will basically allow for both prompt and file level compression to happen within LLM pipeline. So I will be able to have my LLM Lingua be, compressing my prompts and making sure that they're standardized and they're optimized, hyper optimized for my agents to do their work properly with lower infrastructure cost, and also ensuring that the loss in the middle problem and other limitations that come with context rot does not occur. So that's already happening. But while that's happening, all of the files that I'm sending in, specifically from the Tavili extraction, they're also being compressed through these approaches: the textual n-gram abbreviation and the numeric quantization. And through their own research, they found a 95% accuracy while a 60% cost reduction from frontier LLMs while using this approach. So it's definitely a result which works. And that's why I'm using this research paper. But that is what I've understood. And with that in mind, I'm going to take a quick little 5-minute break just to let myself, kind of relax a bit. And then I will be back. All right, I'm back. Okay, so feeling very, very good with this. So, um, okay, so let's just go right into design then, since we are actually no, let's not skip. I was gonna skip related work, but we should probably go through that since it is actually part of the design uh, of the compact prompt pipeline or compact prompt framework. It's just that it's like not their own work. It's just part of it, right? But yeah, let's go through it. See if we understand it. If we need to go through it a little bit more. I'm not gonna get through this whole research paper in the matter of like 1 hour. I only got through 2 pages, and there's like 14 different pages, so I'm definitely not going through all of it. But hopefully, I get through a very large chunk of it, which will be really nice. But yeah, let's go through this. Okay, related work. Selective context is a pioneer. Selective context, a pioneering, a pioneering, a prompt compression method enables LLMs to process 2 times more content while saving 36% memory and 32% inference time using uh, Vikinia 13B, and I'm assuming that is a model because 13B is signifies 13 billion parameters, which it is from LMSys. Awesome. Okay. Okay. Back to work. In summary generation tasks, it uses self information to identify and delete less informative parts of prompts and employs species syntactic parsing to ensure grammatical integrity. Oh. Space CY. Nice. So, something I've realized, just a little bit of a yap, but something that I've realized, while working in the tech space is that a lot of the groundbreaking technology is just building atop abstraction layers, right? It's building atop a technology and work which has already been made. You know, Someday, hopefully for me, you'll see that I'm using Compact Prompt as just like one part of something groundbreaking that I'm building, right? So yeah, you're gonna see that a lot in this paper too. I'm assuming you're gonna see a lot of just work, which is not exactly from BNY or from the team who wrote this awesome paper, but obviously it is still definitely important and it's still impressive because it's connecting these systems together, which is a skill that we need, right? Uh, so yeah, I'm gonna go through all of this, but the plan here is that I'm gonna finish related works today, go through the design as well, and then I'm not gonna go into the actual understanding of the textual n-gram abbreviation or hard prompt compression. I understand the high level of it, what it does, and stuff like that. I understand it in a technical level, but I just don't understand it in a low level technical understanding. But I do want to, so I will. But yeah, so for now, I'm just gonna go through 2 and 3, and once I'm done that, I want to actually just spend some time reviewing and trying to understand if this is something that would work out for us, and I have a high likelihood of saying yes because of the way that this is structured is exactly what we need, right? And once I get that, I'm going to make a doc for this over here. So I'm just going to maintain a documentation for it, and that is the work for today. So as you can see, there was no coding that was done today per se, but it's definitely very important to have some of these days where you engineer, right? Usually it's a mix of like engineering and coding, But today was just pure engineering because I wanted to really go through this paper and get a crack at it. I really enjoy reading these papers as well. Um, but yeah, awesome. Okay, so I'm just gonna go through this now. So remember, selective context is basically a way of compressing the prompt, and the way that it does that is by using a scoring system to see what information is less informative or not really needed within the prompt, and then just removing it. And then it uses a syntactic parsing method from space cy to ensure that when they deleted these less informative parts, that didn't break the grammar or the grammar structure of the prompt, because that can also affect performance, because now the model has to think about what the user is really trying to say, right? Okay, let's move on to the next bit over here. LLM Lingua achieves up to 20x prompt compression with minimal performance loss using trained language models. It employs a coarse-to-fine compression method featuring a budget controller for semantic integrity. Okay, so that was a lot of words, but trained language models, which is basically the LLMs that we know, and it employs a coarse-to-fine compression method. So, this approach significantly reduces. So it optimizes its data by initially applying broad high-level reductions to remove significant redundancy. So it first removes redundancy, what it sees a lot, which is not really needed, and then it applies detailed and targeted refinements, and that is used to preserve essential information. Okay, awesome. And a budget controller for semantic integrity. They should really have some explanation. They did a really good job giving me like a really good brief so far, but this part, it could use a little bit more of context. Like for example here, right, I obviously don't really need to know how the syntactic parsing works, but at least I know the function of what it's doing, right, which is that it's ensuring grammatical integrity, right? In this case, I don't exactly know what the budget controller does. So that's a piece of feedback that I would give to the team at BNY. I think it was an internship that did this. Not fully sure. Okay, so that's I guess you can think of it as the balancer. It's what basically ensures that you're not reducing your prompt length to the point where you're reducing or diluting the meaning or the semantic integrity of your prompt. Okay. Another method is nanocapsulator, which transforms an input prompt into a succinct natural language summary, which is fed into the target LLM. By pruning, again, pruning just means removing, but by pruning irrelevant content and reconstructing fluent sentences, its fine-tuned Vicuna 7B compressor runs independently of the downstream model. Unlike off-the-shelf summarizers, Nanocapsulator incorporates a semantic preservation loss to retain task-critical meaning and a reward function to optimize prompt utility, boosting end task performance. So what this basically means is that it's using the Vicuna model again. I've seen that here as well through selective text, right? A selective text uses the Vicuna 13 billion parameter model. This one uses the 7 billion compressor. And what this does is it incorporates a loss, right? Which ensures that, the actual meaning of the task is not reduced or diluted in any way. and it provides a reward function, which just means that the model is rewarded when it keeps task critical information, which ensures that it does this more often, leading to an increase in the performance. On the downside, the extra compression network incurs memory overhead, and its two-stage inference pipeline demands more compute than simple encoding, right? Because it has to go through the semantic loss and then the reward function as well. Beyond these, two other general hard prompt compressors have emerged. Long LLM Lingua, that's what I'm using now, extends LLM Lingua by reordering documents and recovering subsequences subsequences to double the effective window. While Adacomp, so basically what this means, very simply, is that it takes the function that the LLM Lingua is doing and extends it for larger text by reordering documents and then recovering subsequences, which is basically just taking a sequence and making a sequence off of that within the text. And that just essentially all of this just doubles the effective window of the actual model, right? So again, don't need to go too in depth, but basically it takes the function that the LLM Lingua does and it extends on top of it. While Adacomp adaptively selects context based on query complexity and retrieval quality. LLM Lingua 2 further refines this via data distillation to build compressed corpus and a classifier that predicts which tokens to keep. Although prior work has studied a variety of hard prompt compression and soft prompt rewriting strategies, remember that a hard prompt compression, remember this is used, so probably we should have went through this, but yeah, hard prompt compression is basically used to reduce the length of the LLM prompt, and they do that by directly manipulating the actual text, the natural text of the prompt. And that's what, these techniques do, like selective context or LLM Lingua, right? Whereas the soft prompt will basically convert the text into vector embeddings. Okay, so soft prompt compression actually transforms the text, the prompt, into embeddings, right? And that those embeddings the model can understand because they represent the relationship in a multi-dimensional space, and that basically optimizes the prompt for internal AI processing. Hard prompt is more about removing the actual text that you're sending into the LLM, whereas soft prompt is actually changing the prompt itself to be optimized for the LLM. So likely a mix of the two is probably best, which I think this is doing. Although prior work has studied a variety of hard prompt compression and soft prompt rewriting strategies, we found no existing method that directly applies n-gram abbreviation in the context of prompt pruning and data compression. Most known approaches either operate at the token removal, filtering, sentence level selection, or generative rewriting. Awesome. So what we're basically doing is we are using hard prompt pruning, which I just talked about. It will basically remove parts of the prompt to make it less dense, and because of that, you have lesser amount of usage within the context window, because these prompts are sent into the context window and kept in the context window for referral within later subsequent interactions. But on top of that, it's also implementing n-gram and also the numeric quantization techniques as well, which we see has boosted the performance based off of the research that they've done and the results that they have found. Our combination of hard prompt pruning, n-gram abbreviation, and numeric quantization is novel and addresses a gap in the literature by allowing interpretable, reversible compression that leverages repeated multi-token patterns rather than purely individual token importance. Hard prompt pruning targets redundant or low-level content in natural language prompts, preserving semantic meaning while reducing token count. Our hard prompt compression strategy leverages both static and dynamic self-information measures to identify and prune low-level content from the input prompt, ensuring that the most informative tokens are preserved within a user-specified budget. N-gram abbreviation complements this by focusing on repetitive patterns in attached documents, offering lossless compression for domain-specific terminology or common phrases. Numeric quantization addresses the often overlooked issue of floating point precision in data-heavy contexts, all allowing for a significant reduction in token usage for numerical data while maintaining an analytical fidelity within user-defined error bounds. This holistic approach ensures that CompactPrompt can effectively compress diverse input types commonly found in real-world LLM applications, from text-heavy prompts to data-rich attachments, without requiring model retraining or sacrificing human readability. Okay, so I'm not going to get into the actual nitty-gritty of how that works. I'll leave that for tomorrow. But from the looks of it, of what I have went through, this looks like a very promising paper. I'm going to actually make just some rough notes here and then ask Claude to make it into a very nice not repository, but markdown file that I'm going to add into my docs. And then I'll also add into my Obsidian later on. Not right now, but maybe in the near future. I'm just going to call this Compact Prompt Context Engineering.mg. I'm not going to add anything to it right now. I'm just going to create it so that I know it's there. And I don't forget, because sometimes my dumbass does that. But yeah, awesome. Okay, it's almost 10, so I do want to go to sleep pretty soon. But I want to finish this before I do that. So let's quickly go through this, and then I'm gonna hit the sack for. Yeah, I'm gonna hit the sack after this. But yeah. All right. Okay, so I'm just gonna turn off my microphone now because I'm just gonna be writing stuff out. So for the rest of the stream, I'll be off. decided that I'm just gonna handwrite them so that I'm processing that information. I'm just gonna paste it into the GitHub for now, and then once I'm done tomorrow, hopefully, or day after, I will parse it through AI and make sure everything's good to go. Decided that I'm just gonna By the way, just a note, this is the error, right? The real number is 342 million, but instead of representing that, we represent 300 million. They're roughly the same, but not exactly the same. And obviously, this is a huge error of 42 million, which would probably not happen in a real model. Like, this is just an example. However, however, there's obviously going to be an error, which is what I'm trying to represent here. And users can obviously tweak the error as I explained in this over here. Is a trade-off. The more of the error, the less your compression can be, and therefore more infra cost, because more tokens are being parsed by the AI model. So now I just provided justification, keep it short, sweet, concise, to the point, of why I'm even doing this in the first place, because you always have to start off with understanding why. Why is this needed? And then moving forward. But this is the reasoning behind it, which is a sound reason. So now I can actually get into delving more deeply into the actual technology, because I always start off with high level architecture and then go more deeply into it. And then once I have a good understanding, then I will start implementation using Claude Code and Python. But that is it from me, honestly. What I'm going to do is I'm just going to make this available to anyone with viewership. I'm also going to give it to Kershav. And what I'm also going to do here is I'm just going to add it. April 20th engineering session. There we go. So now it's added into our actual repo, and that's it for me, honestly. Yeah, that's it. So I'll see you tomorrow. I'll try to live stream tomorrow's session, but I'm definitely going to be reading that research paper again. I might not live stream it though. We'll see. We'll see what happens. If it's too late, then I'm not gonna live stream it. Live stream it. But yeah, take care. I'm gonna go to bed now.